Welcome to lesson 3 on factorial expressions and equations. I actually love this lesson because it's pretty algebra-like, and that's kind of in my wheelhouse. So x squared plus 10x plus 24, we want to factor these things. So just as a quick review, let's remember that trinomials are in the form ax squared plus bx plus c. I want to find numbers where the sum is equal to b and the product is equal to c. So you may, c, a times c. You may have seen this as something plus something equals b, something times something equals a times c. You might have just listed some product. I know that I've done a cross where this is my b, this is my a times my c. You can represent it however you want, but I'm going to do the cross. So in the top, I put my b value. So this is 10. And in the bottom, I do a times c. So 1 times 24 is 24. And I need two numbers that multiply to give me 24 and add up to 10. So those are 4 and 6. So remember that when I have a coefficient of 1, then the numbers that I choose for my sum and product are just the numbers that go in my factors. So x plus 4, x plus 6. Okay, let's try this guy. So my sum is -7. My product is -60. So I am looking for two numbers that multiply to give me -60 and add to give me -7. So those would be -12 and +5. So my two factors are x minus 12, x plus 5. And my last guy here, x squared plus 9x minus 36. So I would have my sum is 9, my product is minus 36, kind of squished there. So two things that multiply to give me -36 and add up to give me 9 would be +12 and -3. So x plus 12, x minus 3. Okay, so we're going to need those skills in a little bit here when we are going to simplify, and then we are going to solve. Okay, so we'll start with simplifying. Just a quick reminder that when I have n factorial, what that means is n times n minus 1 times n minus 2 times n minus 3, and so on and so on and so on, right? 5 times 4 times 3 times 2 times 1. So if I have n plus 1 factorial, what this means is, so I have n plus 1, and then I want to decrease that by 1. So if I subtract 1 from that, I get n. And then I have n minus 1, n minus 2, etc., etc., etc. Okay, so that's the top over the bottom. So n minus 1 times n minus 2 times n minus 3, etc., 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 etc. So if you look, you can see that the n minus 1, n minus 2 is the same on the top and the bottom, so those can cancel away. So I'm left with then n plus 1 times n, which if I distribute that n into that bracket, I end up with n squared plus n. Okay, let's try this one, n factorial. So this is going to be n times n minus 1 times n minus 2 factorial, because it would be n minus 2, n minus 3, n minus 4, whatever, keep going. The reason I stop it there is because I looked ahead and I knew that on the bottom I have n minus 2 factorial. So those will cancel away, and I'm left with, when I distribute into my bracket, n squared minus n. Okay, let's do one more. So n plus 2, so it's n plus 2 times n plus 1 times n minus 1 factorial, right? Because that's going to keep going down. And again, the reason I stopped is because I looked at the bottom and I see that I have an n minus 1 factorial. So I know that those can cancel away. Now I need to multiply n plus 2 times n plus 1 times n. So I'm going to do the monomial into that first. So I have n plus 2 times n squared plus n. Just, it doesn't matter what order you multiply in, right? And then I'm going to multiply through this bracket. So this is going to be n cubed plus n squared plus 2n squared plus 2n. which simplifies to n cubed plus 3n squared plus 2n. Simplified algebraic expression. Okay, now we're going to solve a few equations. So we're going to put those skills to use. So we're going to solve these equations. N factorial over n minus 2 factorial equals 90. Okay, I'm just going to zoom in nice and close on that, guys. So we're going to start the same way I did up top. So I'm going to simplify this expression, n times n minus 1 times n minus 2 factorial, because that would keep going down, over n minus 2 factorial equals 90. So I know that those are going to cancel. So I'm left with n squared minus n equals 90. Well, when I have a quadratic, I know that I need to, this will be going back to your foundations 20, move everything to one side. So I'm going to subtract 90 equals 0, and then we factor it. So I have a sum of minus 1 and a product of minus 90. So my two numbers there are going to be minus 10 and positive 9. So my factors are n minus 10 and plus 9. So if these two things equal to 0 when I multiply them, then one or the other must be equal to 0. So I'm going to add 10, n equals 10, or n equals negative 9. Well, from the definition of a factorial, we can't, because if you go back to the beginning and put in negative 9 for n, we can't have a negative factorial number. It's only the natural numbers. So that is not a solution. So n is equal to 10. Okay, let's look at the next example. Number 5 here. N plus 1 factorial over n factorial equals 6. So we're going to do it the same way. We're going to simplify. N plus 1 times n factorial, because that would just keep going down, over n factorial equals 6. This one looks nice and easy because these are going to go away. So I'm left with just n plus 1 equals 6. I'm going to subtract 1 from both sides, and I get n is equal to 5. Right? So let's take away 1, take away 1. So n is equal to 5. It's a natural number. I'm good to go. That one was alrighty. Let's take a look at number 6. This one's maybe a little bit scarier looking, but we can still do it. So we start the same way. So n times n minus 1 times n minus 2, et cetera, I guess, over n plus 2 times n plus 1 times n minus 1 times n minus 2 equals 1 over 6n. I didn't have the foresight in that one to see it, but here's my part that cancels away. That one goes and that one goes. So I'm left with 1 over, when I multiply my bottom, this part through, n plus 2 times n plus 1. So that's going to give me n squared plus n plus 2n plus 1 equals 1 over 6n. Now I'm going to cross multiply and simplify at the same time. Hopefully that's okay. 1 times 6n is 6n. And 1 times this stuff will move to the top, but can I also at the same time put together my like terms? So I will have n squared plus 3n plus 1. Move everything to one side, so I'm going to subtract 6n. So I have 0 is equal to n squared minus 3n plus, I have a multiplication error here. There should be a 2. I was thinking that didn't factor. That's how I knew I had a mistake. So my sum is negative 3. My product is 2. So negative 2 and negative 1 are my numbers. So I've got n minus 2, n minus 1. So I set each of those equal to 0 and solve them. So n is equal to 2 and n is equal to 1. Both of those would be fine if I checked them back in here. I can have 2 factorial over 4 factorial and 1 factorial over 3 factorial. So both of those are acceptable answers. So I've got 2 answers to go there. Okay, so you can go ahead and practice. I've got lots of these for you to practice with. These are super fun, so enjoy.